All right, folks, it's Bass Action, back in action here. In this video, we are going to look at the distance formula. I want to actually develop that distance formula for you in case you haven't seen that in a previous class. We'll go through a more advanced example, and then we're going to just very briefly look at an example with midpoint. All right, so we're going to start off with our distance formula, and although you guys probably know it, maybe you've forgotten it, I want us to look at where that formula comes from that might help you remember it if you have forgotten it. So what we're going to do here is we're just going to give ourselves just a nice little XY axis. We're really only interested in looking at the first quadrant. So we're going to give ourselves an XY axis. We're going to pick two random points. It doesn't matter. I am going to put them nicely on a couple little coordinates, but you'll notice that I'm just choosing them arbitrarily. Nothing significant about these at all. So I've chosen 2 points. I've drawn in the segment. I'm going to label the distance between those 2 points D. Now I'm going to label these 2 points X sub 1 and a Y sub 1 at the first point, and at my second point, I'm going to call it X sub 2 and Y sub 2. Now, it didn't matter which point I chose to call point 1 and point 2, really made no difference at all. Now, again, you might already remember the distance formula, but what's most important here is where does that formula come from? And in case you haven't seen it before, here's what we're going to do. What we're going to do is we're going to draw in, and I like to do it with some dotted lines, and we're going to draw in this vertical and horizontal, making a nice right triangle there. If we do that, then what we can think about is the distance along the horizontal would be the difference between these two x coordinates. So I could write that as an x sub 2 minus an x sub 1. Remember, I could do it the other way around, doesn't matter. And then my vertical distance here on this little triangle is going to be the difference between the two y coordinates. So that would be y sub 2 minus y sub 1. The order I do this one has to be the same as the order of that one. We do want to always be thinking about a consistency there. Now, if we think about Pythagorean theorems, since we've created a nice right triangle, we can set this up and simply say our distance squared, that would be our hypotenuse squared, would be each of our legs squared. So we're going to have the sum of those two legs. So applying our Pythagorean theorem, we get our formula right here. And then if we just continue our solving, taking the square root of each side, you will see that sure enough, our distance is the exact formula that we already knew that it was going to be. So what I really want you to remember here is that distance formula and the Pythagorean theorem, they're the same darn thing. So you can think Pythagorean theorem, you can think distance formula, but these go hand in hand, and that sometimes makes it a little easier to remember where the formulas, what the formulas are and where they come from. Now, little example here. Instead of just doing a little basic distance formula like we've done so many times in our lives, we're going to look at one that's a little more advanced. I'm going to tell you that the distance of some line segment is 5 radical 10 units, okay? And the endpoints of that segment are going to be the point 10, 2, and U is going to be the point X, 11, okay? So you'll notice that I've got a variable floating around in here. So what we want to understand is how are we going to solve this using our distance formula. And there's really just a couple little algebra things that we've got to be careful about here. So we're going to go ahead and set this up. I like to go ahead and jump straight into the more Pythagorean theorem setup where I've got my distance and I'm going to square that side, and then I don't have to worry about that big square root if I don't want to. Now I'm going to subtract my x's, and I like to do x minus 10 to keep that variable positive. That's going to be a quantity squared. Subtract my y's, 11 minus 2, quantity squared. I'm going to square my radical. Remember, we're going to try not to use our calculators here if we can help it. 25 times 10 is going to give me 250. Remember, this has to be a binomial squared. So one option here is to expand this out And I'm going to expand it, but I'm also going to show you another way in just a second that we can do this. I can have my x squared minus my 20x plus my 100. My 11 minus 2 is my 9, so I'm going to add in my 81. Now, this is certainly one option to do here, and a lot of students like to do this. If you take this method, you will need to move everything over and factor. I want to give you another option though, and what that one's going to do is I'm going to keep this piece just like this. So we're going to have an x minus 10. I'm going to leave that x minus 10 quantity squared. I'm going to subtract my 81 from the other side, and that's going to get me 169. Now what I can do is I can take my square root of each side, because this is now set up to solve by square roots. And now when I look at this, I have a plus or minus 13 and an x minus 10. So now I can more easily get to, especially thinking without a calculator, I'm going to have my 10 over here. So 10 plus 13 will give me a 23 is one of my answers. And a 10 minus 13 is going to give me a -3 is my other answer. So that might be easier to do without a calculator. So just an option. The next thing I want a quick look at here is midpoint. So I'm just going to give myself a little dividing line here, and I want a quick talk about midpoint. I'm not going to write the formula. I'm just going to write in general what it means. We want to take the average of the x values. We want to take the average of the y values, and that's going to create a new ordered pair. So again, let's say that I have a segment AT. So I'm given segment AT, and I'm going to tell you that A is at the point 3, 1, and the midpoint of AT is at 7/2, -5. And I want the coordinates for point T. Now, what I like to do is I like to go ahead and write out that the coordinates of point T are going to be an XY pair. From there, what I can do is I can just think, okay, well, how would I get this midpoint? Well, I would average my x values. So I would take this x value and this x value, and I would find their average. I would say x plus 3 divided by 2, and I know that that has to equal this x value that has to be in the middle. Now, quick solving this, you can either multiply both sides by 2, that will of course cancel our 2's, or in this case, you can easily even look at the fact that these numerators are going to have to be equal. So my x coordinate is going to be 4. I'm going to repeat this process with the y's. I need to average the two y values together. So I'm going to say y plus 1, and that's going to equal a -5. So y plus 1 is going to equal a -10. So my y value is going to be a -11. So my final answer for point T should be the point 4, -11. Oops, I didn't mean to put that extra little line there. Let's get rid of that. There we go. So we've got 4, -11 as our final answer for that point. So being able to work our formulas forwards and backwards is going to be much more important at this stage of the game than just the basic, simple workings with the formulas that you would have done in your previous classes.